for formulation of the LPP, then graphical method. In your graphical method, how you'll have to solve it, your procedure was being told, and then how to find out your maximization, minimization with your given problem. Then we went into your simplex method. We went into what is your solution, your feasible solution, optimal solution, what is your slack variable, what is your surplus variable. Okay, till that we have finished. Now we will write down the steps to find out your simplex method so that you'll be able to understand how you can do it when you do the problems. Okay, so in your simplex method, what you'll have to do is first step is to see whether your optimization function is your maximization or your minimization. That will be your first step. So if at all it becomes minimization problem, what is your first step is you will multiply that minimization function into minus of whatever value and take it as your maximization function. Okay, so write your step 1. Check whether the objective is minimize or maximize. Okay, write your steps, put today's date, write your heading as steps to find your feasible solution using your simplex method. Put your heading as steps to find feasible solution. You're doing it in your simplex method. Your simplex method, what is it is in your linear programming, if your variables is more than 2, okay, if your variables is more than 2, you'll be using your simplex method. Okay, whereas if your variables are only 2, you will be using your graphical method. Okay, write it down. This will be your step 1. Your step 2. Check whether all PIs are positive. PIs is positive means you have to see all your variables must be greater than or equal to 0. Okay, so that is what is written. Check whether all your PIs are positive. If any of the BIs is negative, multiply both sides, of that constraint by minus 1. Okay, this is very important. You'll have to multiply both the sides with minus 1. Okay, you multiply by minus 1 so as to make it positive. So as to make it positive. So that will be your second step. So your first step is to see whether it is a maximization problem or a minimization problem. If it is a minimization problem, what you do is you will throughout that function, you will multiply it with minus sign and make it to maximization problem. And then your second step is you will have to see whether all your values are positive. If at all it is not positive, you will multiply both the sides by minus 1 and make it to less than or equal to. Okay. So when you make it to less than or equal to only in the constraint, you can use your maximization problem and use your slack variable. Yesterday we wrote the definition. No, when you will be using a slack variable, when you will be using a surplus variable. Slack variable means it will be addition. Your surplus variable means it will be subtraction. Okay. So your step 2 is that. Your step 3. step 3. The step 3 will be by introducing slack variable using slack variable. Your slack variable we denote it as SI. Okay, SI. Your slack variable by introducing slack variable convert the inequality constraints. Convert the inequality constraints convert the inequality constraints into equations and express the LPP as a standard form. You'll express it in your standard form as a standard form. So the given question will be in your canonical form. You will change it to your standard form. How do you change it to your standard form? By introducing this slack variable. Okay, you will be introducing a slack variable. How many ever constraints are there? Accordingly, you will write your slack variables. So that will be your step 3. So your step 4. Find an initial basic feasible solution. Find an initial basic feasible solution. Find an initial basic feasible solution and express in the following table. Express in the following table. That table I will do it and express in the following table. This table format is only very, very important. You have to understand what and all must be there in the table. Okay, that only we will be using for all the problems. Okay, so you're going to find out your initial basic feasible solution. That will be your step 4. Okay, have you all finished writing your step 1 and your step 2? Your step 1 is to see whether the given condition is maximization problem. If at all it is not a maximization problem, what you'll have to do, you will multiply it with your minus sign, okay, and make it to maximization. So after that, what you'll have to do, your second step is to see whether all your constraints are your non-negativity constraints. That is, it is all positive. If at all it is not positive, what you do is you will multiply both the sides with negative sign -1 and you will make it to positive. Okay, that will be your step 2. After that, your step 3, what you'll have to do is your inequality constraint, you will have to change it to equality constraint. So for that, what you'll have to do, you have to have less than or equal to. So that you will introduce the slack variable by adding it. Okay, your slack variable, you will add it, whereas when it is surplus variable, you will subtract it. But here, whatever problem we are dealt with, we will be using only a slack variable and we don't use your surplus variable. For your portion, you don't have surplus variable. Okay, only we have your slack variable. So for your slack variable, what you need to have is you have to have maximization function. Okay, so that you will substitute your slack variable. After doing your step 3, what you will have to do is you'll have to find out your initial basic feasible solution. For that, you have to find out the table. For that, I will write it on this side. Okay, so I will drop your step 1, step 2. Have you all finished writing? Yes?
Yes, ma'am.
I will draw that table. So under the step 4, you draw this table. Okay. It is a big table, but it is very easy on me. It will be CB, YB, XB, and then your X1, X2, and so on. Okay. And then you will use your slack variable S1, S2, and so on. Okay. So this will be your tabular column. So how many ever variables are there? That many variables you will write. With that, you will write your slack variables. Okay. How many ever slack variables you are taking, that many slack variables you will be taking. Writing it down. Okay. And above this, it will be CJ. Okay. J. Write it as CJ. CJ is on top of it. And here it will be your values, your function, which is nothing but your C1, C2, and so on. This will always be 0. Okay. I will tell you what is this all. Okay. First you write down the format, then I will tell you what and all this will represent. Okay. So this will be the tabular column. This is actually etc. Okay. And similarly here also your slack variables. Okay. In any number of slack variables, any number of variables. This the students are waiting in the lobby. One of you take in charge to let them inside. Then they will can come inside. Instead of me putting them inside, you try to put them inside. Anishwar is there inside. Ragul, Ragul take in charge of admitting everyone inside. Danush is also there. Yeah.
Ma'am, mobile
One of
I'm
you
logging
take.
on.
That's okay. In mobile also you can do it.
Okay, ma'am.
Okay. Try admitting everyone inside. But I need not get disturbed with the class. Yeah. So write down this tabular column. And here what you'll have to write is your CB is nothing but your coefficient of your max function. Okay, your coefficient of your, they will give you one function, isn't it? And that you write down the coefficient of your slack variable. Okay, so that will, you will take it as C1, C2, C3, and so on. Okay, that we represent as CB1, CB2, CB3, and so on. Okay, and similarly, this will be your YB will be your slack variable. How many ever slack variable you are denoting? So many. Okay, that will be your YB. Your XB is nothing but in your equation you will write it as less than or equal to some value. Okay, 20, 30, 40 less than or equal to. That value you will write it here. So that will become B1, B2, B3, and so on. How many ever variables are there? And this your x1, x2 will be nothing but your a11, a12. That is your way, that equation. You will write the coefficient of that value. Coefficient of your x1 in that first equation. Coefficient of your x2 in that first equation. That you will write. And this will be 1. Okay. For the first equation, your slack variable you will add. Okay. So for the first equation, you will take plus S1, whereas your S2 will become 0. Okay. Similarly, if there is S3, that will also become 0. Okay. And here again, here it will be A21, A22, and so on. Here it is the second equation. So here your S1 will become 0. plus S2 will be, you'll have 1. Okay. When you do the problems, you'll understand. This will be the same. Okay. And here it will be A31, A32, and so on. Okay. And your last term, you have to find out your Zj minus Cj. You have to find out Zj. Your Zj minus Cj will be, this will be your Z0. This is nothing but what you will have to do is, so your Zj minus Cj is nothing but you have got your values here, no? Your B value and values which are your variables coefficient. Okay, your slack variables, whatever you have taken, that variables coefficient you are taking it. That you will multiply. You will multiply. Okay, you will multiply and write that value here. Okay, when we do it with numbers, you will understand. Okay, similarly here, what you'll have to do, you will have to multiply, and then you just put minus Cj. Your Cj values are on top. Okay, whatever values on top, you will write that value with a negative sign. Okay, if it is 0, you will write directly that 0 itself. Okay, but if you've got your values for your C1 and your C2, you will put it as Zj minus Cj. You have to multiply it, and then you will have to subtract it with these values. So you will be writing it as Z1 minus C1, Z2 minus C2, and so on. Okay, this will be the tabular column. When we do the problem with numbers, you will understand, but you have to listen properly. Write it. I will write the notation of what all these things are. Have you all finished with your step 3 and your step 4?
Yes, ma'am.
Okay. So I will write what is your notations of all these things that you can understand little more clearly. So your Cj will denote the coefficient. Cj will denote the coefficients of the variables. Coefficients of the variables coefficient of the variables in the objective function. In the objective function. So you know what is your objective function. Okay, you will take your maximization problem only. So maximization z is equal to, they can give you like 2x1 plus 4x2 and that's all. Okay, so you will take only the coefficient of that variable. So here what you will write, that 2 and that 4 value you will write it here. Your other slack variables will be 0. Okay, you will be writing a slack variable 0 there. Only the variables which you have taken from the question, you will write the coefficient. That will be your Cj. Okay, that will be your Cj. Next will be your Cb. Cb will be the Cb will be the coefficient of the basic variables. So these basic variables are the variables which we are adding. Okay, basic variables in the objective function. You can write in bracket objective function. These basic variables are your slack variables. Okay, your slack variables will be your basic variables. So what is your Cj? Cj is the coefficient of the variables. Variables means your x1, x2 and so on will be your variables. Basic variables are your slack variables. Okay, slack variables or surplus variables. But we are dealt with only slack variables. So your basic variables coefficient will be your Cb. Okay, in your max function, only your slack variable, when you take it down in your maximization function, it will be 0. Okay, you will add, put it as plus 0s1, 0s2 and so on. Okay, so your CB will be coefficient of the basic variables. You can write in brackets s1, s2 and so on. Okay, in the objective function, that will be your CB. YB, your YB, your YB YB denotes the basic variables. So how many of our basic variables are there in your question? That will be your YB. YB is your basic variables. Okay, YB is your basic variables. XB. So XB denotes the XB denotes the values of the basic variable. I will tell you how to find out the basic variables value. Okay, that will be the values of the basic variables. Okay, that will be your XB. And your final one is your ZJ minus CJ will be your ZJ minus CJ will be the net evaluations. That net evaluation will be your step 5. Okay, till here you just write what is your notations. Then I will tell you what is your ZJ minus CJ, how do you calculate. So till here, did you understand how you are writing your tabular column? First step is to write your CJ. CJ is nothing but your coefficient of your variables. Okay, coefficient of your variables you'll be writing, that will be your CJ. After writing your CJ, you'll have to write about your CB. CB is nothing but coefficient of your basic variables. Okay, your coefficient of your basic variables is your objective function. Then your YB. YB is your basic variables. How many of our terms you have found out? That basic variables you will be writing here. Your basic variables is nothing but your slack variable. Okay, and your XB will be, you will find out the value of the slack variable. Okay, that value you will substitute it here. Okay, after that your ZJ minus CJ is nothing but your net evaluation. Have you drawn the diagram? Have you drawn the tabular column? This is your step 4. Next, your net evaluation, I will deal it with your step 5. Have you all written it down? Write it down. Write it down. It is very, very important. Simplex method is very, very important. 16-mark question. I will take out that one, because let this tabular column be, because with the tabular column only I'm going to write the next points and all. Have you all finished writing your notation?
Yes, ma'am.
So we will go on to step 5. Step 5. Step 5. Compute the net evaluation. Now we are going to do that net evaluation. What is that? Zj minus Cj. With that only we have to conclude. Okay. That only we have to find out. So you're going to compute the net evaluation. So that evaluation is nothing but your Zj minus Cj. That is what you're going to find out in your step 5. Okay, compute the net evaluation Zj minus Cj, where your j is equal to 1 to n. Where your j is equal to 1 to n. By using, you're going to use the formula Zj minus Cj is equal to, you will find out how you'll find out is, you have to multiply your CB. Okay, in your tabular column, you've got your CB. Okay, you'll be having the CB into this XB minus your CJ. Okay, this will be the formula. So when you write it down, write it as CB is CB into your XB. Your XP, how they have written is as your CP into AJ they have taken. Okay. So how do for each every term? Okay. For your for this value, you have to multiply a CB1 and B1 minus this term for this term. Okay. And for this term, if you see, it will be CB1 into A11 minus your C1. Okay, this will be the usual format. Okay, when we do the problem with numbers, when you do, it will be easy. Just now you write the formulas. Okay, so that it will be easy when you go through it. Okay, now in this itself, we have two options. Okay, you will have two options. So there, if all your Zj minus Cj is greater than or equal to 0. So if it is becoming greater than or equal to 0, that will become your optimal solution. If at all, if it is not greater than or equal to 0, that is not your optimal solution. Again, you'll have to do the iteration. Okay, so this first tabular column is just your initial basic table. Next, what you'll have to do is you have to find out your Zj minus Cj. If at all it is greater than or equal to 0, you can stop with it. Okay, that will become the optimum solution. But if you don't get an greater than or equal to 0 and get negative values, then the problem again starts. Okay, so right, if all this is greater than or equal to 0, then the current basic feasible solution, then the current basic feasible solution is optimal. Then the current basic feasible solution XB is optimal. With this, the problem itself will solve. Okay, but if at all if the condition changes for if it is less than or equal to, okay, if at least 1 Zj minus Cj, at least 1 Zj minus Cj is less than equal to 0, then the basic feasible solution is not optimal. Is not optimal. Then the basic feasible solution is not optimal. Okay, so this will be your step 5. Okay, in your step 5, you're going to find out your Zj minus Cj. In your Zj minus Cj, you have to multiply and get the value. Okay, after getting that value, here, this will be your Zj minus Cj. That if you're getting all the values greater than or equal to 0, that is, if you're getting a positive value, that will be the optimal solution. If at all you get the negative value, Then what you do, you go on to the step 6. Okay, you'll go on to step 6. Okay, so have you all finished with your step 5? I will tell it from the first. Your step 1, is you'll have to see whether your problem is maximization or minimization. If at all it is a minimization problem, you will multiply it with your negative sign. You will multiply it with minus and make it to maximization problem. That will be your step 1. Second point, you have to change all your BIs to positive. Okay, that is, it has to be multiplied with -1 on both the sides. That will be your step 2. Your step 3 is you have to change your inequality constraints to constraints. So by introducing the slack variable, okay. So canonical form, you will change it to standard form by introducing the slack variables. That will be your step 3. Okay, step 4, you will formulate this tabular column. Okay, your tabular column you'll have to formulate and tell what is your CJ, what is your CB, YB, XB, and what is your ZJ minus CJ. Okay, you have to know that table. After that, you have to find out your ZJ minus CJ. In that, if it is greater than or equal to 0, you get your optimal solution. If it is not greater than 0, and if you're getting a negative value, then we go on to step 6. Okay. So now I'm coming this side. So since we have all done, have you all finished your step 5? Otherwise, if you finish step 5, I will do it. Have you written your step 5?
Yes,
Otherwise,
ma'am.
I will drop this. Okay. We will go on to step 6. Your step 6. Your step 6, we write it as to find the entering variable. Find the entering variable. Find the entering. So this again, you have to know the tableau column. Okay, in the tableau column, whichever Zj minus Cj was negative. Okay, whichever value is negative, that value you have to see. Okay, so it was like this. No, the tableau column was like this. Okay, and it was like this. Your Zj minus Cj. Okay, and here you had your Z naught. Here you've got some value like -5, and then your -1, then 0, 0, and go on. Okay, so on. So when you find out your Zj minus Cj, you have to see the most negative value. Okay, not the smallest value. You will see the most negative value. So here, if you see -1 is there, -5. Here, the most negative value is -5. Okay, that -5 will become your most negative value. The corresponding column you have to see. Okay, the corresponding column you have to see. And what you'll have to do with that corresponding column is you have to see which value is bigger. Okay, whichever value is bigger, with that value, okay, some value like you've got like 2 here, and then you've got 7, and then you've got 9, then 3 and 5. Okay, in this whole column, whichever is your biggest value. Now, if you see, your 9 is your bigger value. Okay, 9 is your bigger value. This bigger value, with that bigger value, the whole row, you will divide it. Okay, you will divide it and find out your min ratio. Okay, that will be the next step. Okay, so we write the heading as step 6 and write to find the entering variable. To find the entering variable. So under that, the entering variable, the entering variable. I'm making you to write these steps because when you do the problem, you won't understand. If you have the steps, you will be able to understand. Okay, so only I'm making it sure that you write the steps. So please write it down, otherwise you won't understand the simplex method. Each step is very, very important. Okay, so write it down. The entering variable is the non-basic variable is the non-basic variable corresponding to the most negative value. I told you, no, in the most negative value you have to take. Okay. So in your most negative value of your Zj minus Cj, you have to take the most negative value. You must not be taking only the just any negative value you can't take. You have to take the most negative value. Okay. So that most negative value you will have to take. In the next line, you can take it as the entering variable column, the entering variable column, is known as the key column. Known as the key column. You can be asked in one word. This key column is also called as pivot column. Pivot. Okay. It's also called as pivot column. Okay. So this is your step 6. So in your step 6, what you have to do is you have to see a most negative value. That will be your step 6. In your Zj minus Cj, you have to find the most negative value, and in that most negative value, you will circle it. Okay. After circling it, you will find out that column from which column is most negative. So that column we call it as key column or pivot column. So that will be your step 6. Write it down.